All for coming today. First and foremost, I know that there's some other really exciting things going on, but this is a really exciting presentation and demonstration of a lot of different things that have been accumulating over the past probably 20 years. Is anyone here a filmmaker by any chance? Does anybody tell stories with Unity? Anybody tell stories with Unity? Anyone do any computer animation or graphics? How about VFX people? Cool. Then you're going to love this. This is also a little bit of a history lesson, which is very interesting. The first thing I'm going to do is talk about myself. So my name is Ron Martin. My involvement in computer graphics goes back to 1989. I've had the luck of working in this industry, which is very rewarding, very powerful, a lot of work that goes up on a big screen, yet there's a lot of little things that we never see, a lot of work behind the scenes as well. My background started in broadcast and education, meaning I did a Master's of Fine Art Education, was a teacher, and that led me into computer graphics. I started working at television stations and then training people in 3D animation. I went to work at a place called Softimage in Montreal in the early 90s. That software got its kickstart by a gentleman named Daniel Langlois, and the claim to fame was that Softimage was used to animate the dinosaurs in Jurassic Park. That's not the Forgotten Kingdom or anything like that. That's the first Jurassic Park. Anyways, while Softimage was being used at Jurassic Park, there was a lot of other people that were starting to work in the animation and visual effects industry. One of those people was part of a company called Digital Monarch Media. We'll get to that in just a second. So my career went from working in software, working in production, working in senior management of different facilities, the last one being Digital Domain, where I built a studio in Vancouver, then the studio in Florida, and I was building out a studio in Abu Dhabi. After that, I went and I started a makerspace that was doing all sorts of prop work and very interesting stuff in Atlanta, Georgia. After that, I went to work at Unity. Now, one of the partners of Digital Monarch Media is a gentleman named Wes Potter. Wes and I worked at EA at the same time, and Wes worked on Need for Speed, 007 game, another Need for Speed Carbon, and then he met this gentleman named Habib Zargarpur, and they were both hired at the same day at EA. So Habib I had known from back in the Industrial Light and Magic days, and Habib was a visual effects supervisor there and a technical artist. And he worked on Star Wars, The Phantom Menace, The Perfect Storm, and Twister, both of which he received a BAFTA for the visual effects there. Now, when we talk about Unity in Hollywood, this goes back a little bit further than most people actually understand. Habib and Wes had worked on The Jungle Book. Then they took some technology that they had been developing at Microsoft, and they were employed by the production team there and used The Jungle Book as a springboard for a virtual production technology which they had developed. They wound up using motion capture and working back and forth. They also worked on Ready Player One and Blade Runner. Both of those movies used the Unity engine with the Digital Monarch Media Toolkit for digital cinematography on top. So when we think about this, one of Habib's lines is that the future of film is with real-time tools. And what that means is that we want to be able to see what we're working on. How many people here have spent hours and hours rendering? How many people have been disappointed by the time that they wait hours and hours for their rendering only to see that it didn't turn out quite the way they wanted to? It's a common theme, being kind of let down by that CPU process of rendering. So one of the things I'd like to show today is a piece that Habib had worked on. Part of this effort goes back to understanding what the camera was doing in computer graphics. We would work with a storyboard, and the storyboard would be one shot, and all the animation and all the visual effects were produced for that one shot. With the Phantom Menace, Habib noticed that it was easier to do all the animation on one scene with one plan, load the terrain and everything in all around it, and then be able to play that all the way through and pick the camera shots all the way along. This is one of the most famous sequences in The Phantom Menace, where in the pod race, they had picked out different places and put the camera throughout to make that story play a little bit better. The action and everything else flowed a little bit along the way. So this is another sequence. Habib had worked on a movie called The Perfect Storm, and The Perfect Storm primarily took place at sea. And in this instance, they had a tank full of water in a soundstage. And as you can see, all the blue screen that was put up there. They had used ocean simulation, and this is one of the things Habib had worked on, was all the particle simulation for this huge sea swells and surges. So the most difficult part about this was pre-visualizing how the action of both the boat and the camera crew were going to work in harmony. And by putting in a camera rig into the virtual environment, they could see what fit in the soundstage, because it's very challenging in working not only with water, with actors, with buoyancy, and all the things that can happen when you're running waves, to make sure that the camera is able to capture what the director started out to make. Now, Habib left Industrial Light and Magic and went to work with Wes at EA. During this time, they were working on Need for Speed, and one of the aspects of Need for Speed that was required of the game was for the camera to disengage from the third-party or first-party or hood mount camera to be able to tell the story afterwards of what happens when you crash your car and you get arrested by the police and they come in and take you away. Well, in order for that to happen, I know that sounds very simple now with tools like Cinemachine and Timeline, but at that point back then, it was a very difficult thing. So they created this piece of extension onto the game engine called ICE, or In-Game Camera Editor. And this allowed the creatives to break the gameplay and pull this camera out and be able to tell some of the story. And that was a huge advancement. Now, what else happened during that time was the debug camera in the game engine. When you're flying that thing around inside of the game, Habib and Wes both kind of dawned on this idea of, why don't all cameras in virtual environments do that? Why doesn't that happen in all game engines? So they applied that technology also to James Bond, Everything or Nothing, and then another game called Skate, which was at Electronic Arts. And we got into this thing, it's like the idea of a paradigm shift of the virtual production and how real-time engines would tell or change how films were made. This idea of a virtual storytelling is a very powerful visualization tool, allowing artists and directors to be able to go through a process and check to see if their vision actually translates, both visually and into cinematic language. Then, this is Habib on the left, and he met this guy named James Cameron. And in 2010, Habib and Wes did a proof of concept for the next Avatar that was going to come out, and it's still in production. But they proposed a process by which they could stream motion capture into the game engine and then control their camera system at the same time. They did a very successful test for James Cameron. I've seen the videos and the tests, and even though I can't show it here for copyright reasons, it really did sell them on using virtual production in a way that they had never thought of before. So along comes this idea of exposure. Wes and Habib called their new technology exposure. The technology they had developed on the James Cameron project, they called Photon, and Photon is a very interesting step on the way to their new system, exposure. So I'm just looking at a couple of shots here. This was something that they had done while at Microsoft with the Halo assets. So they hooked up a motion capture suit, rigged it to the Halo assets, and then did a real-time ray tracing program built again on top of Unity. One of the interesting things about this accomplishment was that they had to put 32 graphics cards into servers and run them in a specific room, which was cooled only for this one test. So the real-time ray tracing has come along hugely since that time. I'll show you this test, and this is something where you can see they actually had a Cook Torrents shader that worked with the real-time renderer, and they got the Cook Torrents shader from Weta, where they were doing this test. Oh, gosh, when I play movies, can you guys see the movie? Oh no. Here, I've been showing you a couple of cool movies here on my laptop, and you didn't see them, and I'm sorry. Okay, let's try this again. Do you want me to change one of the... That's all we had to do. PowerPoint still challenging after all these years. So as you can see, this was a project that they assembled over the course of the day, taking these assets and putting them into into Unity, and with this real-time ray tracer, they were able to feed the virtual production camera into the mocap or into the engine, and also stream the mocap at the same time. Habib is very proud of this piece, primarily because they were able to set up all the assets by simply dragging and dropping them into the engine, arranging the lighting so it looked good. And this whole scene took 20 minutes to set up. They basically, one light, all the materials, they came right into Unity and all worked. So let's go. This is another one of those shots. So this is a gentleman named Alex McDowell. Alex is a production designer, and he worked with Wes and Habib on a Disney project, again, built on top of Unity. At the time, it was called Group of Seven. And Alex had worked on some movies with David Fincher, including Fight Club and Panic Room. And then he had worked on Minority Report, and also did production design on The Watchmen. Okay. So, how does exposure work? In this particular slide, you can see that the assets come in. Exposure was working as a real-time ray tracing engine. You streamed in virtual cameras. You could have simple controls, and I'm going to be doing a demo of that. And then you had Maya and Motion Builder, which was bringing in the mocap data. When you add a green screen to this whole scenario, you then have a simulcam scenario where you're taking a video feed at the same time and bringing it in and compositing with the live action graphics. All right, let's see how this works. I have a couple more videos coming up. Is that going to be, do you want to hang out here with me? Okay. The next big project I worked on was something called The Jungle Book. Did anybody see The Jungle Book? So Jon Favreau, the director, after doing a test with Habib and Wes, decided that he would use the motion capture data streamed into the game engine, and they worked with actors, blue screen, and the simulcam to be able to visualize what the aspects of the production would look like. First, before they got on stage, and then while on stage to capture all the data and put it into the film. And then MPC took that data and with Digital Domain and turned it into the movie that we saw. This is a visual representation of the virtual film tools designed and delivered for The Jungle Book. You can see it broken up into 4 parts there: production, post, design, and pre-pro. Each of those different aspects falls into one of these pie pieces. The most exciting part of what happens here is that we don't differentiate this work or put it in what we normally call a cascading workflow or a waterfall. We're working all these different pieces at the same time. Then along came this piece with Ready Player One. I'm going to play this little video here. So with Ready Player One, this gentleman, Ernest Cline, who wrote the novel, never imagined that they would be using VR to actually make the movie about VR. So the different people that contributed to the process realized how important it was for everyone to be able to see the world while they were acting or building out the production process. This all, again, was built upon Unity. So any of the developers out there who are working currently with Unity to achieve their gaming or their production or their movie processes, just think of it also not only to create the content, but also as a tool in which you use to expedite your creative vision. In this particular scene, we see Steven Spielberg putting on the HTC Vive, and they're basically picking out camera positions inside of this modeled environment. Being able to move the camera that quickly, being able to frame up shots. This is a really great shot, this before and after, to be able to see where they want to move props or how they can build out this space so that every shot is designed virtually before they go on the camera set. This is the mocap stage which they performed the film in, and they even took the HTC Vive and walked the characters through the environment so that they knew where they were acting and who they were acting with. This changed the way that the production was anticipated. Usually when you go on a mocap stage, you don't see the people that you're working with. You don't see the other characters. You don't envision yourself in that environment. In this regard, they could, and it helped everybody do a better job. And the result was pretty astounding. Now, in this slide, what we saw was the way the work was distributed across the production. Exposure with the Unity desktop was able to be instanced multiple times. So you had 6 different exposures running at once. Wes and Habib designed and developed a communication protocol that worked with Unity to be able to, for each of the different machines to talk to each other at the same time. They were all feeding into one instance of Unity. So if something changed or the director asked for one piece of the prop to be moved or maybe the set to be turned or a light to be added, it fed into Unity and updated all the scenes. So we had a director, somebody doing lighting, maybe someone who is the animation supervisor, the DP, somebody doing rack focus while they were shooting, and every one of those different seats updated the scene that everyone was looking at. So that communication protocol became something called Hermes. So in this slide, you'll see the different parts of exposure, the virtual film tools. You've got Logos, and Logos is a node-based network, again, built on top of Unity. We'll take a look at that in a minute. Hydra, which is their I/O core. This allows physical interfaces to come into Unity. And I'll show you how that works in a second. You've got Hermes, and then you've got Cyclops. And Cyclops is the virtual tracking mechanism for the handheld camera. So here's a screen grab of exposure. And what you see here are different nodes. The transform here is highlighted, and when you highlight the transform while exposure is running, it gives you all the data of the communications and how the information is flying back and forth. So if you wanted to, say, attach a new piece of hardware, maybe it's the focus ring on top of the camera lenses, then that data of how that ring focuses can come right into Unity, and you can mimic that inside of exposure. So this is the rig I'm going to show you today, and this is 2 Xbox Elite controllers, this particular one used the Google Project Tango or a Lenovo Fab 2 Pro as the tracking system. These are different variations of that virtual camera, or the VCam as they call it, and going through different ones, you can see the different pieces that were used. Some of them use, when they're doing optical tracking, they put an optical tracking marker on the handheld device and then calibrate that. Now, this is coming up to another project, the last project that they had worked on most recently, and that's part of the demo I'm going to show you, which is a World War II film. And this is a shoulder-mounted camera, similar to what people use when they're filming, and they weighted the camera so it was the same weight, so that they could interpret or have the cinematographers feel like they were actually shooting. Pardon me. So what does this mean in XR, or what does it mean as other devices are being built? Unity, of course, supports 32 and counting different devices. So being able to work alongside of different technologies allow people to use like a head-mounted display and tracking devices in order to visualize the different parts of the scene. Now, these guys had a really good break when they when Habib was consulting on on Blade Runner 2049, and in this particular instance. Okay, good, thank you. So this is a visualization of a scene, and this was part of a directorial session with Denis Villeneuve, the director of Blade Runner. When they originally started to do this shot, they had 2 shots that were connected, and every time they tried to fly the spinner the way that it was planned, it crashed into the tower. So they realized very quickly that doing things the way they used to do, by pre-visualizing things in Maya, keyframing the camera, didn't give a very good impression of what the physical space was really like. So in this specific space, and in this shot, Habib first flew the spinner around the tower. And in this scene in Trash Mesa, the people that were on the ground were shooting up at the spinner. Does everybody remember that shot? So as that was happening, they figured out, well, if somebody was shooting at you, they would just climb and try to gain some altitude. So that's what they did in this shot. And Habib first had Denis fly the spinner, and then he put the camera, the V-cam, in the spinner, and that's what created that secondary motion, thus connecting the two shots and creating a much more successful performance. I think I have that. Yeah, so we'll watch that one more time, and then we can watch the shot the way it was in the film. So these are the actual assets that were done here. Okay, let's go to the next one. This was another shot that proved to be a very challenging shot. During this piece of the film, they wanted to show the Wallace Towers, and these are these huge buildings that were created, and it was so hard to discern between the scale of the city, how big these towers were, and the animation that was going on. So let's just play that one. Oh. So in this particular shot, they just did a subtle push in, and Habib was flying the spinner, and Denis was working the camera head. So they were both feeding into the same shot. Here's another example. In this specific shot, they actually were working on storyboards for 2 months to try to nail this shot down. Instead, by loading in the pre-visualization model and flying a drone, the camera was then created to emulate that way that a drone would fly. So Wes built a physics engine inside of Exposure that allowed the drone to fly like it would, as if it was actually being piloted by somebody else. Another specific shot that they added life to. This is one shot that was originally storyboarded in this way, and the pre-visualization artists created this shot. But as you can see, it's pretty dead. It doesn't have a lot of life to it. Then they did a shot in Exposure and put a subtle dolly in, and it changed the way that shot appeared in the film, gave it a little bit more life. Does anybody remember this shot? This specific shot was created to, again, show the scale of the seawall between Los Angeles and the wasteland that laid out towards the ocean. Let's see here. Now we're going to talk a little bit about Greyhound. Greyhound is a World War II naval battle movie. It was, as you can see, C.F. Forrester's book, The Good Shepherd, interpreted, and it was a fairly small production company that took on this large-scale objective. So what they had decided to do for Greyhound was visualize the full movie. So they built all the different parts. In this instance, You'll see the ship and how things interact with the ship and how exposure works. They built the ocean, a 4-kilometer square piece of simulated water. They used a partnership. Habib works very specifically with engineers at NVIDIA to build a shader which was called WaveWorks. They have the VCam tracking, the ship simulation. So the ship is actually being simulated by the waves, and then character animation that was made in Maya. All this fed into Unity and Exposure. Then they, shot for shot, made the whole film with VR. There was a little skepticism off the start of the film in the pre-production process. So 6 Maya artists over the course of the first day did 12 shots. And then the cinematographer and Habib worked in the other room, and they were able to create 300 shots. And that shows you the efficiency of being able to work in a virtual environment. And those 12 shots that the Maya people created didn't have any lighting or any effects or any shadows, whereas Habib's piece, and as you'll see, is a fully functional flow of the visual. In this specific illustration, we show the old pipeline. And the old pipeline would have shot 1, people would animate the scene, they would keyframe the camera, then they would play blast that shot, it would go to editorial, they would review that shot, give notes, feedback, and it would go over and over through different areas and styles of refinement until they got it right. They would do shot by shot. And different people could be working on different shots. The problem with that is to try to create something that's seamless and join all those shots together. Now, in this exposure scenario, they animated 42 master scenes or sequences by taking mocap and doing 5 days of mocap. They could take all the different characters that are in the movie, run it through a recorded session, and then put them into exposure and cut the sequences. So now you've got an animated master scene, and with the real-time pipeline, you can perform camera 1, camera 2, camera 5, camera 4, and then you can edit them after the fact. This is John Bruno, who's the DP of the film. He's sitting down here because apparently it was a long day. And standing up and working a camera all day long, even a virtual camera, can be kind of tiring. And that's Habib standing beside him. So I'm going to go in and we'll take a look at this demo first. I'm just going to minimize this. We'll jump out and I'm just going to set up the demo. So now we're using a Google Pixel 3. Just by firing that up, I'm using a small portable router. And it's, let's see if I can get out of this thing here. And we can launch our exposure. These specific configurations allowed us to take each of the different sequences and create a playable. This can also run in the engine. Okay, great. Oops. Sorry about that. So I'm just going to make sure I'm on the Wi-Fi here. Yep. We'll turn on our controllers. Okay. And I simply just, there's an app, a Unity app that's running called Cyclops on the phone. We just tap that to connect. And it's amazing how you can see the scene kind of wake up once you have the handheld camera. We've got the controllers, and we're using two controllers to give the sensor the feeling of the camera. So as we look down, we can see the waves, the shader that's working on the waves. We look over, we can see the ship. Now this ship is over 1 million polygons. The water is simulated at 4 square kilometers. Now, I'll show you this. I'll just take a bookmark and I can play that scene, and you can see all the effects, all the visual effects, the smokestacks. You see everything running during the simulation. You can see the little guys motion captured down there. As I move the camera around, oh, and there's the plane. Now, that's a little fast. The motion's a little fast. But, this is to the point where I can walk all the way around the ship. I can change the speed of my motion. And now this is the drone simulator. You can see as I'm moving around, it's got its own inertia. And I can shoot segments of the movie this way. So right now, I'm in the smokestack. One of the things the director wanted for the film was to be able to shoot from ship to ship. At one point, they had 40 different ships in this in the sequences that they were shooting. So I'm just going to turn around and change my speed of my rotation as well. And let's go down a bit here. Come down. Now, all these different rigs, oops, I'm still, the different types of things you can do in here. So if I go into the set, I can go into staging and I can move things around the set. So if there's something I need to change, I can go in and edit that. If I wanted to go back, I can go in and change the lighting. So what's interesting about the lighting setup is that, let's move this a bit. I'm just going to go up. Look over at the ship. Raise the camera. All right, here we are. So if I go into the lighting here, edit the lights, inside of this section, in each of these different ones, I can change the light from a point light to a spotlight. I know it's very subtle, but you can see the changes up there. I can then slide along to the other settings here, light 1, light 2, light 3, and the lights themselves are different colors. So you can go in and you can change the hue value of the light and get a totally different look. Or I can change the temperature. And all of this is in cinematography kind of language, the different lights. They're, we're using kelvins to do the change. And then we can go in and we can also change the, position of the light. If we go over here and we take a look, we can then go back, turn the lights on and off, and be able to cycle through the different lights. Now, what's interesting is after I've done all my takes, and say we change the time of day, I can then go back and change all the lights on any given sequence of shots I've created in a non-destructive manner. And I can save that setting. So we'll apply those changes now. Okay. Now, when I'm shooting the ship-to-ship sequence, I can look down and I can see the water. Move the camera around. So in this specific rig, what I'm going to do is I'm going to lock myself to the floating boat. And to do that, I'm going to change my rig from a drone, and I change that to I can have a plane or flight, a tripod, a rail cam, and I'll explain those, a dolly. In this case, I'm just going to use the base. So the camera base then becomes anchored, and you can see that little anchor there. So in this specific case, the director wanted to see boat to boat. Where did I lose my ship here? He wanted to see boat to boat and wanted to feel like we were at sea. So I'll turn around here. So now the camera isn't floating on its own. You can see the focus. I can double tap, and you can see the T-stop. So I can change the T-stop on the different shots. You see what the aperture does there. I can then look at the distance, and if I double click, I can focus to that distance. So as I'm shooting, and I'm just going to tilt this up a little bit here. Change my speed again. There we are. So as I'm shooting, I am attached to the boat, and as I play this, set you'll see the animation of the ship, and the ship to ship shows me moving where the camera is anchored, and gives me a very realistic feeling of live at sea. So let's do one take, and I'm going to move from the bow across in this take. So I'll pause this animation. I'll rewind the animation. Now this is something that's amazing to be able to do with an engine, especially a game engine, is frame accuracy. And this is something that was very difficult for these guys to do, because as you may know, game engines will run as fast as the card and the hardware will physically be able to create. So I'm going to go back here, and I'm doing a jog wheel shuttle to be able to go back in that animation. I just want to get the plane as it starts to come in to frame and before any of the guns go off. And I'm going to hold down and record. You'll see down about 3, 2, 1, and here comes my take. Okay, and then we'll pause that. So remember that take, and now we're going to go in and use the, we'll go in a little closer. We'll lower us down. You can see all the details of all these guys. And we're going to lay in now a dolly alongside of the ship. Okay? So we go in and we say, let's change that now to a dolly. I can click on that and go into a dolly grip. Whoops. And we can see the actual track that I'm going to be laying down. We'll come up a bit. Oh, I think. And I can rotate the dolly. And I'm going to put it down alongside of the ship there. Okay, and just to show you how this works, I think I've lost my tracking there. Let's see. To show you how this works with the grip, I've actually got the camera controls right on top of here. So I can dial in the different lenses as they're working. I've got to, let's see, come up a bit. Oops. I think the speed's a little too much. You can see how much coffee I've had today. Oh, yes. So we'll bring this way down. We'll tilt the camera up. There we go. All right, now let's move this dolly. Now, as I move the camera, you'll be able to see I'm moving down the dolly track. So I'm constrained to the dolly track, but I can still do my camera position on this side. So let's set this up for a take. And the first thing we'll do is set a bookmark. And then we'll hold this down, 3, 2, 1. And we'll look along as we go. Okay, there's my other take. Now the last one I want to do, okay, we'll take ourselves off of the dolly and we'll go to something called the base again. We'll go in and say, okay, now in this specific one, I want to go find the plane and anchor myself on top of the plane. So the plane's over here. And on this specific one, we'll jog wheel back. And we'll capture this take. Okay, pause that. And now we'll go over to the front where the plane is. Now, let's go speed up a bit here. Now, what's interesting if you could hear the audio on this, the plane is emitting a sound. So as we're actually flying around this plane, we're hearing the spatial audio at the same time. So let's do this. Let's go down to the base. We'll anchor this onto the base again, and then we'll do one more take. I like the propellers in there, so I'm going to go up a little higher, looking down. Okay, let's do that. Okay, 3, 2, 1, take. And then we can look as this goes over and then take. So now that we're running a little short on time here, so now what we're going to do is we'll go in and we'll review our different shots. So review, oops, view takes, and we can go down. These are all the different takes that I've done. So let's take 8, 9, 10, and 11. And then going back up to the top, we can review those takes, play selected, and we'll see all the different shots that we made with our animation. Okay, here's our first shot, ship to ship, following the plane overhead. Ship number 2, which was our dolly shot, moving the camera along. Here's the better dolly shot. And then here's our plane shot. All of the data and what's most important about this aspect of the production is that all of the camera data, the lens data, the focal distance, the duration of the shot, as you can see, the time code, and all of that information can be exported as an FBX file to go into another piece of software if need be. So by being able to continue and make that flow of information from the visualization to the production and then go onwards is a very powerful communication tool to the company that's going to do the final visual effects on this film. So I'll load, let me see if I have enough time here to get into one of the Blade Runner sequences that we saw, just to kind of show you. We'll see how this is going to work here. So again, the same scenario. And what's interesting about this scene is that this is the MPC pre-visualization sequence that was created for this shot. Again, I'm in the drone. Oops. Don't point the camera at the shiny monitor, whatever you do. It'll tend to skip out on you. You can see all the water there. In this particular setup, all these assets were created by MPC for the visualization of the film. And then the spinner was actually the spinner created by Double Negative and the one used in the film. So as you can see, those shots, the way that they were produced by Habib and the director, Denis Villeneuve, and all the assets there. All pretty exciting stuff. So what we hope to do over the next couple of movies with this is advance the simulcam technology to be able to composite live action shots inside, and then also be able to export all that data using an SDI card so that we can actually have the live footage at the same time as we're doing our virtual production. It's pretty wild stuff. All right. We've got 5 more minutes. Are there any questions?
Any questions?
Nothing?
Anyone have any questions? All right. If not, Ron will be available after the hall.
We got one.
All right, one question.
Hey, Ron.
Hi.
So the work Digital Monarch is doing is great.
Yeah.
But what if we want to try something?
So,
I mean,
yes.
working with James Cameron and the lot is one thing, but if we want to use this in our own production or find some way to do it, is there
Yes.
anything?
So currently what we're doing, currently we're offering this as a production service. So if somebody has a film that they're going to make, or they're involved in an opportunity to make a film and they want to save hundreds of thousands of dollars, then we'd come and help. It's a small team. We'd train people on site how to use the technology, leave them with the kit, and then they can continue to use it.
Hi, Ron. This is outstanding. So
Hi.
I was lucky enough to have to attend a similar session that Habib did at IBC this year,
Yes.
and it was again outstanding. I had a long chat with him, and
Yes.
I think it was the film head of Unity along with him.
Yeah. Matthew
so
Mueller.
So essentially, what I had spoken to him about, and what I'd like to talk to you about as well, is how do I build this into academia and into teaching?
Yes.
Because whether it's filmmaking, whether it's animation, whether it's VFX, we are teaching them a particular workflow, a particular pipeline based on certain tools. Obviously, we're teaching them the craft,
Yep.
but the craft is based on the tools.
Yes.
Now, and this is something that goes on a big picture with Unity as well. If we have to build in filmmaking on Unity as part of alternative tools pipeline that
Yes.
students need to learn and know,
Yeah.
how do we start deploying that, right?
So-
So how do we, what are the, so this is something that Habib said he'd get back to me on, but I'm assuming he's busy, is to
Yes.
have, what are the prerequisites that students need to have before they can get on to Exposure, Cyclops, and Unity and this tool? What is actually their training process for this, and then how do we evaluate their quality of work?
So digital cinematography is a fairly new, accessible way to work. So in the past, hundreds of thousands of dollars worth of equipment, more than $250,000 worth of motion capture stage and equipment is required in order to do this. We've used the perception neuron or the Extends, and we've recently partnered with Rococo to have a plugin for Unity. So with very little capital, you can start doing productions. one of the sides, one of the caveats of working with Digital Monarch Media is that we would love people to learn more about digital cinematography. So if you're an accredited institution offering a degree or a diploma, we can come and set you up with a kit. So we currently have one at USC. There's another kit going in over in Copenhagen. And these are two other, very predominant and prestigious film institutions. So I don't see why we couldn't set one up here in India. Oh, yes? Nice. We should work it out. All right. Well, thank you very much for coming to my talk. I know that we're standing on the shoulders of greatness here, where we've got giants that have built our stage for us to stand on as far as this comes. But as the head of Unity says, John Riccicello, the world is a better place with more creatives. So I hope that everybody will take this idea of making films in Unity away with them. And even if you're shooting live action films, doing production visualization in real time is a really fantastic way to make sure that your shots all make sense. Probably be a little bit better than mine, take a little bit more time with it and create something that's a little bit better. But again, thanks for your time, and congratulations on being a fantastic, part of a fantastic community. Thank you.
Thank you, Ron, for a great 1 hour.
Thanks.
Just something from the organizer.
Oh, thanks. I hope we'll see some of you up here next year.